Now, let us see acids and bases in laboratory. We can identify whether the solution is acidic or basic by the following observations. First, substance by change the color state, and substance by change the odor. Observations and learning about identification of acids and bases in laboratory by using indicators. Please note that olfactory indicators are those indicators that help to identify whether the given solution is acidic or basic by changing their smell in spite of color as other indicators do. Vanilla, onion and clove can be used as olfactory indicators. Let us do experiment for each in the laboratory. First, let us do an experiment to understand whether the state of the substance or solution change by color. Here, we will see how hydrochloric acid will change the color for different type of indicators. For this experiment, the apparatus required is watch glass. The chemicals required for this experiment are dilute hydrochloric acid, red and blue litmus papers, methyl orange, phenolphthalein. We need to take few precautions while doing this experiment. Hydrochloric acid is corrosive in nature. So, take dilute hydrochloric acid, which contains much more of water in it. Let us start the experiment. Take the watch glass and pour a drop of hydrochloric acid on the watch glass. Keep the blue litmus paper on hydrochloric acid drop on watch glass. We observe that the blue litmus paper change its color from blue to red. So, the solution which turns the blue litmus to red will be acidic solution. Apply the first two steps for the remaining indicators. That is red litmus paper, methyl orange and phenolphthalein. Record the changes. We see that hydrochloric acid remains same color for red litmus paper. Hydrochloric acid changes blue litmus to red. Hydrochloric acid becomes colorless when phenolphthalein solution is added. And hydrochloric acid becomes red after adding methyl orange. The conclusions for this experiment are: the solution which turns blue litmus to red will be acidic solution. The solution which turns red litmus to blue will be basis or alkaline solution. This experiment procedure also applies to all following solutions: acids, sulfuric acid, nitric acid, acetic acid. Bases, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, and ammonium hydroxide. Let us see in detail each one. Sulfuric acid remains same color for red litmus paper. Sulfuric acid changes blue litmus to red. Sulfuric acid becomes colorless when phenolphthalein solution is added. Sulfuric acid becomes red after adding methyl orange. Nitric acid remains same color for red litmus paper. Nitric acid changes blue litmus to red. Nitric acid becomes colorless when phenolphthalein solution is added. Nitric acid becomes red after adding methyl orange. Acetic acid remains same color for red litmus paper. Acetic acid changes blue litmus to red. Acetic acid becomes colorless when phenolphthalein solution is added. Acetic acid becomes red after adding methyl orange. Sodium hydroxide changes red litmus to blue. Sodium hydroxide remains same for blue litmus paper. Sodium hydroxide shows pink color when phenolphthalein solution is added. Sodium hydroxide shows yellow color after adding methyl orange. Calcium hydroxide changes red litmus to blue. Calcium hydroxide remains same for blue litmus paper. Calcium hydroxide shows pink color when phenolphthalein solution is added. Calcium hydroxide shows yellow color after adding methyl orange. Potassium hydroxide changes red litmus to blue. Potassium hydroxide remains same for blue litmus paper. Potassium hydroxide shows pink color when phenolphthalein solution is added. Potassium hydroxide shows yellow color after adding methyl orange. Magnesium hydroxide changes red litmus to blue. Magnesium hydroxide remains same for blue litmus paper. Magnesium hydroxide shows pink color when phenolphthalein solution is added. Magnesium hydroxide shows yellow color after adding methyl orange. Ammonium hydroxide changes red litmus to blue. Ammonium hydroxide remains same for blue litmus paper. Ammonium hydroxide shows pink color when phenolphthalein solution is added. Ammonium hydroxide shows yellow color after adding methyl orange.